What we're going to do today is a Corona tracker in Spring Boot. This is a finished application that we're going to build. As you can see, list quite a few important data for each place, such as confirmed, recovered, and active. And for each of these columns, we're also going to show the changes that took place. We can also paginate, and there's also a search bar. You could search for the Netherlands or any other places. So let's get into it. First, let's go to start.spring.io. This is a great place because you can easily set up a base project with all the dependencies, and you can pretty much set up it correctly with good names, and you can set pretty much all the main components up quite quickly. So in this project we're going to use Maven, Java, we're going to use the latest release version. So as you can see, it doesn't actually say release, it just misses that part. So 2.3.0 is the latest release version. You're also going to need a group name. This is actually whatever you like. Usually this is the company's name or the app's name, so we can leave it as the example. Artifact is the module's name, so in a group you can have multiple modules. And for example, in a microservices environment, each module could perhaps be a microservice or not. So for example, we could name this app. Description is arbitrary, it just describes the project, what it does. The package name is the composition of the group and the artifact. Packaging, I'm gonna leave it as char. This is fine because this is like a runnable zip file, so you can run this on the JVM. On the other hand, with a WAR file, you'd need to run it inside of a server such as Tomcat. And with the jar, you usually have an embedded server. Java, we're going to use Java 11, and you also need to set up the dependencies. We're going to need Spring Boot DevTools. As you can see, it provides fast application restarts and also live reloads as well. So this is quite handy tool. We're also going to need Lombok, so we don't need to write or generate that much boilerplate codes, such as basic getters and setters and certain constructors. We're also gonna use Spring Web, which is the standard blocking MVC project. It by default has a embedded Tomcat server, which is fine. Then we also gonna need a template engine such as TimeLeaf, but you could choose any other. But in this tutorial we're gonna use TimeLeaf. We could perhaps add a persistence related dependencies as well, such as a database and Spring Data JPA, but we're gonna leave that to later. So later we're also gonna need a MySQL adapter, MySQL driver as well, and the Spring Data JPA. Leave it to that for now. So once we click this together, we need to click on generate and then save this zip file. Then we're gonna unzip it and either open it up with IntelliJ IDE or Eclipse. Both of them have a free version. You can choose whichever you like. However, I'll be using IntelliJ IDE. So in the meantime, I've just downloaded this new base application. Okay, so once we unzipped it, we need to open it up, and what you need to do next is to open it up with either IntelliJ or Eclipse. And here you can see the basic structure of this application. So as you can see, we're going to put all the Java files, all the controllers, services, repositories, everything is going to live here. In terms of Java classes, then all the CSS, JavaScript files are going to live in the static folder, and the templates folder is going to contain the timeleaf template files. The application.properties file contains all the all the Spring Boot application properties, all the configurations that we're gonna need. So in the future we're gonna use a MySQL database, and that's gonna need some credentials. However, we're not gonna use the .properties file, but a YAML file. So I'm gonna replace this with a YAML file. Let's create it under resources. Properties.yaml. Fine. We could write all the tests into this place. As you can see, this class is annotated with add spring boot test, and you could write methods like this with the add test annotation, and this would start them one by one after the other. So all the automated tests could reside under this folder. You could perhaps create other packages to better structure the test, but we're not gonna get into that. And last but not least, here's your pom.xml. This is the Maven file. You set all the dependencies here, all the required dependencies that you're gonna need in this project. So as you can see, we're using timeleaf, we're using the Spring Boot Starter web dependency, also using Spring Boot DevTools, Lombok, and by default we also get this starter test, so we can write tests. We also said that we're gonna use Java 11, and here's the name, the artifact ID, the group ID, the same as we said previously. So pretty much after we click this together, we got this project, which is quite neat because we can straight ahead start writing controllers, services, and templates, and we could really get something up and running quite fast. You could also see that this application class is annotated with add Spring Boot application. This specifies, so this basically tells Spring that this is a Spring Boot application, not the normal Spring application. So it's gonna wire up certain configurations by default, which are pretty good actually. If there's something that you'd like to do differently, such as using another embedded server, so say you don't want to use Tomcat, or you'd rather use Netty because of various reasons. It is by default non-blocking, so maybe it has better performance as well. But then you can actually tell Spring that you don't really want to use Tomcat, but then it's actually gonna use Netty instead. So it's not a problem, but you get some sensible defaults, or you can pretty much get up and running faster because of these sensible defaults. Okay, so let's create a controller. It's important to note that all the controller classes need to end with controller. So we're gonna create, for example, a main controller, and we also need to annotate this class with @controller annotation. So this way Spring is gonna know that this is gonna be a controller. Right, and here we can write all the methods, and each of them is gonna be a controller. So we could write, for example, public. We're gonna need string because we're gonna return a template. So in the return part of this method, we're gonna return the name of the template file. So this is gonna be string. We're gonna name it root, and we're gonna return main template. So we're gonna need to create this main template.html file. And last but not least, we're also gonna need to annotate this with @getMapping. And we also need to tell the path that it needs to monitor. Okay, so whenever the user hits, so makes a GET request on the root path, then this method is gonna be triggered, and this main template file is gonna be returned. Okay, so let's create this main template file. So main template, or actually we could create an HTML file. So main template. So with this we get some sensible defaults here. So in the title we're gonna write Corona Tracker. Okay. And in the body we could write something like hello world. Okay, so we're gonna write hello world inside this h1 header. Let's start this up. Okay, so it's, oh yeah. Another application is running, so I need to close it first because this port is currently busy. So let's start this up. So as you can see, Tomcat initialized with port 8080. Tomcat started port 8080. So as you can see, it started and the whole application is started. It took 1.6 seconds to bring it all up. And if we come here, localhost 8080, then we can see our hello world application. So as you can see, we're actually hitting the root, and so we're generating a GET request to the root path, and then, so because of this annotation, this GET mapping annotation on the root path, this method gets triggered. This is called, and we return the main template, which is here. So as you can see, this is pretty cool. However, we can add another cool thing too. So we could add some models as well. So if you write model, We also need to import this model class. Then we can actually inject certain variables into our templates. So if you write model.add attribute, the first one's gonna be the variable's name. So this is gonna be test1, and the next one is the value. We're gonna write hello user. So what we just did is we actually inject actual data into our template, so into this main template. So we set a variable and enrich it with hello user. However, we could also use a object as well. So let's try it out. Let's create a h2 header, and we are gonna write this, and it's called test1. We could use it this way too, or we could write it another way too, and it's like this. So we're gonna need th, so this is timely specific tags. So we're gonna need th text, and then the variable, which is test1. And then what we're gonna do is just rebuild the project. So this is actually quite fast. As you can see, it only took 0.3 seconds compared to 1.6, and this is so we got this with Spring DevTools. If we hit refresh, we can see that both of these variables are injected into our template, which is quite nice, because this is exactly what we wanted. Okay, so now we have a basic understanding how Spring MVC works. So as you can see, so MVC stands for Model View Controller. So obviously we're going to need the controller. This is the controller, the C part. We need a model. This is the model. So this is the data part. Here we can inject data into the template, and the template is the view. So Model View Controller, MVC. You have the controller, the model, and the template as the view layer. Okay, so this must be clear now. So now we're gonna head over to where our data resides. So let's go to GitHub, and inside the search field, let's type in COVID-19. As you can see, this is Johns Hopkins University's repository that is updated daily with the newest data available. So if we click on this folder and then to the daily reports, we can see all the data that is available. So if we scroll down to the last one, then we can actually see the way it's structured. So as you can see the confirmed cases, deaths, recovered, active, and you also have a combined key. So we're going to use these data. So first of all, let's just download it, and once we download it, we're going to load it into Spring. process it, and then enrich our template with it. We're gonna download this file, so hit on right click and save link as, and then we're gonna head over to our IntelliJ. Okay, so what we're gonna do now is we're gonna create a variable called Csv file, and this is gonna hold the path to our CSV file. So you're gonna write, so this is, I'm using Linux, so this may be different for you, but in Linux you need to do it this way. Then this is my username, so if you have a different username, then you must have a different one. I'm gonna use yours here, and then I downloaded it to the download folder. And last but not least, we need to use this CSV file, so we're gonna use it. Okay, so what we're gonna need now is a CSV processor. So let's get back to our pom.xml, and we're gonna include a Csv handler. We're gonna use OpenCSV. We're gonna import changes here. Okay, so once we have this, we can head back to our controller. Okay, so I'm gonna copy some code over to make this a little bit faster. Okay, so we have a reader, so this is this reader. We instantiate it and give it a file reader inside a CSV file, so this path. So the file reader gets this path to our Corona CSV, and we give this file reader to CSV reader, and then we have this line string array, and we say that we're gonna load the whole line. So this file has many lines, so each line is gonna be stored temporarily in this string array, and this is gonna loop over the whole file until it's over. Okay. And we're also gonna need a few other stuff. So because, as you know, while reading a file, many exceptions could occur. Therefore, we need to encompass this into a try-catch block. Yeah, so it complained because this bracket was missing. Okay, so basically this will go through the whole file, and if there's an error, then if there's an IO exception, then we're gonna print out the whole stack trace, and once everything's over, even if it catches, so even if it throws an exception, then finally it's gonna close the reader. Okay, so once we have this, we actually need to skip the first line, because the first line contains all the column names. So we're gonna create a variable here, and if this variable equals to 0, then we're gonna increase it. Okay, and with this, this is gonna be fine. So this way, we're gonna skip the first line. Okay, so now, let's create a Pojo. Pojo stands for plain old Java object. And let's call it Corona, and this is a class. And as you remember, we're using Lombok. And why are we using Lombok? Well, because with Lombok we can do something like this, add getter, and this way all the fields that we're gonna have here will get a getter generated. However, we can also use this, add setter, or add all args constructor, which is like a constructor that requires all the arguments as required. And we can have no args constructor. We can also have toString, and it generates a toString. And there are many others as well. But perhaps we could add builder, which is pretty much like returning the object once we set a field. So, for example, we set the location name, such as the country name, and then we return the object of it. So this way we can chain the whole object population logic one after the other. Okay, so which fields we're gonna need? We're gonna need the active, we're gonna need recovered, we're also gonna need confirmed, and we should store the last update as well in a local datetime object. And last but not least, we're gonna use the combined key